Hello everyone, how are you? I hope all of you are good and doing well. Just a minute. Yes, let me know. Am I audible? My dear student, am I audible? Yes or no? Am I audible? Yeah. Hello everybody. How are you? I hope all of you are well and doing good. So, you people know that today I'm going to start production technology part 1, right? Production technology part 1 I'm going to deal, and production part technology part 2 is going to cover by Dr. Sudesh Singh sir, right? So this is our first lecture, and in this first lecture I'm going to deal theory of metal cutting part 1, right? This is a part 1 which I'm going to cover. Okay everybody, so let's wait for others so that I will start my session, right? Let's wait for other. Yes. Okay, so let's start today's session, right? Let's start today's session. So here I'm going to start the lecture. So topics to be covered in today's session will be what? Topics is going to cover, like, first of all, I'm going to discuss, I'm going to discuss some basic concept, like what is a single point cutting tool, what is a double point cutting tool, and what is your multi-point cutting tool. Basically, I will cover only single point cutting tool right now, right? So along with that, I'm going to cover the machining, the concept of what? Machining, right? Then the second topic will be your shear plane. The third topic will be tooling angle of simple blade cutting tool, right? So these are the topic which I'm going to cover here. So let's start today's session, my dear student. Now, how many of you know? How many of you know about the single point cutting tool? Yes, how many of you know about the single point cutting tool? My dear, single point cutting tool, basically the example of single point cutting tool, let me write down the example of single point cutting tool, right? Example of single point cutting tool. Let me write down the example of single point cutting tool. Single point cutting tool. Let me write down the example, right? So what are the examples? The tool number 1. Yes. Where's the yes? So so turning tool, right? Turning tool. Okay. Turning tool, and your shaping turning tool, your shaping, right? Next tool is a planing. Okay. Maybe you have seen the planing tool. Planing, planing, right? Plotting, plotting, right? Plotting. Okay. And your parting tool. Plotting tool, parting tool, parting tool, okay, parting tool, etc. There are various examples, right? There are various examples, right? Yes, you people will get your answer very soon. Don't worry about that. I'm not ignoring your comments, right? But there, some point, or at a particular point of time, you will get the right information, right, my dear student? Right? At a particular time of interval, you will get the right information. Okay. So why we here? Why we all are here? to understand the things, to learn the things, right? To learn the things. So don't worry about that. Okay. So don't worry about that. So example of single point cutting tool is what? Let me tell you. Lot of you student have seen the turning tool, right? Lot of the student have seen the turning tool, and lot of you have seen the shaper tool also, right? A shaper tool also, a shaping tool also, a shaping tool. Let me draw the diagram of the shaping tool. Let me draw the diagram of the shaping tool. How many of you them have seen this type of tool which I am drawing here? Please see how many of you them have seen the this type of tool. Yes, this is a tool which I am drawing here. Please see, please see, this is a tool which I am drawing here. Yes, yes, see, this is a tool which I am drawing here, the tool which I am drawing here. Okay, see here. Now see, see, this is your tool. Many of you have seen this type of tool. Yes, tell me yes or no. Many of you them have seen this type of tool. Yes or no? My dear, this is what? This is basically a cutting edge or your main cutting edge. This is what? This is your main cutting edge, right? This is your main cutting edge, right? This is what? Your main cutting edge. So in a machining operation, how many cutting edge is going to participate in a machining operation? How many cutting edge? Only there is only one cutting edge which is participating in the machining operation. That's why we call a single point cutting tool. This is a 3D diagram. This is the 3D diagram, my dear, right? This is a 3D diagram which you have seen, right? Which you have seen. So if you draw this figure in a two-dimensional, you will take the projection. You will take the projection. If you see the tool in this plane, you will get this tool like this, right? You will get this tool like this. See here. See here. Oh my God. Okay. See. This is a tool which I am drawing here. Look. This is the tool, the same tool. This is the same tool. Now you are seeing this tool in a 2D figure. This is what? This is 2D figure, my dear. This is 3D figure, and this is what? Your two-dimensional figure. This is two-dimensional, right? Two-dimensional figure. This is what? Two-dimensional figure. And this is what? Three-dimensional figure, right? Three-dimensional figure. Three-dimensional figure, right? Three-dimensional figure. Here you can see this cutting edge. Now if you see this tool from this way in a plane, then this cutting edge will be look like as a point. Yes or no? This cutting edge will be look like as a point. That's why we call, okay, single point cutting tool. Single point cutting tool. Single point cutting tool. Yes or no? Are you getting the meaning of single point cutting tool? Are you getting the meaning of single point cutting tool? Yes or no? Tell me. Yes. How many of you are getting the meaning of single point cutting tool? Yes. Tell me, everybody. Yes. Okay. Tell me how many of you get the meaning of single point cutting tool. The meaning of single point cutting tool is that how many effective edge is participating? Only one effective edge is participating. Only one effective edge is participating in a single point cutting tool. That's why we call it a single point cutting tool. Now, I will show you one more tool. Now, I will show you one more tool, and that is known as, most of you have seen this tool. Okay, most of you have seen this tool. Now, I'm drawing here. Here, I'm drawing the figure. You have to guess the name. Are you ready? Here, I'm drawing the figure, my dear. Here, I'm drawing the figure. You have to guess the name of this tool. So, are you ready? Yes or no? Are you people ready? Here, I'm going to draw the figure. So, let's guess the name of this tool. Let's guess the name of this tool, right? Let's guess the name of this tool. See here. See here. So, which tool is that? How many? Please comment in the chat box. Please comment in the chat box. The chat box must be filled with your comment. Yes or no? The chat box must be filled with your comment. Yes or no, my dear people? Yes, 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 yes. So, which tool is that? Any guess? Any guess? Any guess? Any guess? Which tool is that? How many? How many? How many people are guessing? Let me know. Let me know. So, which tool is that? Anybody else in the chat box? So, let me know who is guessing the name of this tool. Yes, my dear student. Tell me, tell me, tell me, tell me. Yes. Very good, Manish Kumar. It's a turning tool, right? It's a turning tool, my dear. It's a turning tool. Turning tool. It's a turning tool, my dear. So, my dear, is the turning tool. Okay. So, this edge is known as, this edge I'm talking about, this edge. This edge is known as what? Your main cutting edge, your principal cutting edge. That is your side cutting edge. The side cutting edge. The side cutting edge. And I will tell you, in turning operation, I will tell you, in turning operation, only this side cutting edge is going to participate in the machining operation. This edge is known as what? This edge is known as your end cutting edge. Your end cutting edge. Your end cutting edge. Yes or no? Your end cutting edge. Now, a lot of you will be asked a question, sir, there will be two edges. Sir, there will be two edges. One is side cutting edge and another is end cutting edge. So it must be not a single point cutting tool because there are two cutting edges. So it might be possible, sir. It might be possible that it will be not a single point cutting tool. It will be a double point cutting tool. But no, you are wrong. Your assumption is wrong. What you are guessing is wrong. Let me show you the turning operation. So here I am drawing the turning operation, my dear student. Here I am drawing the turning operation. So this is the turning operation. See, this is a two-dimensional figure which I am drawing here, right? Which I am drawing here, which I am drawing here. You can see. Now, if you are going to see the tool from the top, if you are going to see the tool from the top, so I am going to see this tool. I am going to see this tool. Yes, somebody is asking that. Sir, I am getting 73.33 in ME. How is it for this year, sir? Beta, very good. You are getting very good marks. Don't worry. So, on this marks, what you can get, okay, what you can get, there is a detailed video which we have uploaded on Gate ME channel, right? On Gate Wallah ME channel, mechanical. Are you getting my thing? Where there, Kuldeep sir has uploaded a video that on which mark, or Kuldeep sir is going to upload the video on which mark you will get, okay, which IIT, how to utilize your marks, right, in the upcoming time. So don't worry, be concentrate here. So if you see the tool from the top view, my dear, this is the top view. This is what? This is a top view. Now see this top view. See this top view. Look, this is end cutting edge. Like, this is end cutting edge. See here. This is what? Look, if you see the tool from the top view, okay, if you see, this is the side cutting edge. This is end cutting edge. Yes or no? This is your shank. This is, you can see here, here, this is what? This is a shank, as you can see, right? This is the shank. Okay. Now you can see, my dear student, this is what? This is your end cutting edge. Your end cutting edge, right? Your end cutting edge. See from the top view, this is what? This is side cutting edge. This is side cutting edge, right? And this is the top view of the tool. Yes or no? Yes or no? This is the top view of the tool which I have drawn here. If you see the tool from the top view. So this view is clear. This picture is clear. Yes or no? This view and this picture is clear to you. Yes, tell me. This picture and this view is clear. This is a top view. This is a side cutting edge which I have drawn here. This is an end cutting edge which I have drawn here. So this is a face. This is known as what? Face of the tool. This is a rake face. As you people know, this is rake face. This is rake face. This is what? This is rake face. I will talk about the faces later, but are you getting the exact picture? Exact picture of this tool in a top view? Yes or no? Tell me. Yes or no? Okay, my dear, very good. Now this is a tool. Now this is a turning operation. Please see. Please see. See here. See. See. This is a turning operation, right? Here you have seen that your workpiece is rotating. The workpiece is rotating revolution per minute. Right, the workpiece is fit in work holding device that is known as chuck, and you are giving the feed. You are giving the feed to the tool, that is feed in mm per revolution. In mm per revolution. Yes or no? In mm per revolution. So here you can see only this cutting edge, my dear, in turning. This is what? This is side cutting edge. Yes or no? Side cutting edge. Side cutting edge. Now let me know how many cutting edge. When this tool is going to cut the workpiece, the chip is flowing like this. The chip will be flow like this. Now tell me. Now tell me how many cutting edges going to participate in the machining operation. Here I have drawn the figure of turning, my dear. Here I have drawn the figure of what? Figure of turning. Right? Figure of turning. Now let me know. Let me know how many cutting edges. Let me know how many cutting edges is going to participate. Only one now. Only one now. So this is again your single point cutting tool. This is again your single point cutting tool. Single point cutting tool. Single point cutting tool. Yes? Is that point is clear? Is that point is clear? Right? Now later I will tell you about the double point cutting tool, about the multi-point cutting tool, but later, not right now. Right? But not right now. The single point cutting tool means what? The single point cutting tool means, the meaning of this, The meaning of this, it has one cutting edge. It has one cutting edge. Remember, it has one cutting edge, right? It has one cutting edge. That is a basic meaning. It has one cutting edge. Later, I will tell you the double point cutting tool, the multi-point cutting tool, but later, not right now. Before that, we are going to enter into the next topic. That is what? Machining. That is what? Machining, right? That is what? Machining. Okay. Now, I want to know the meaning of machining. So I want to know from you. Do you understand the meaning of machining? Do you understand the meaning of machining? Do you know the definition of machining? Yes or no? Do you know the meaning of machining? Yes or no? Yes, tapering, taper tool. There is a taper tool, by my dear. Taper tool is also a single point cutting tool. But before that, let me know. Do you know the meaning of machining? Yes. How many of you them know the meaning of machining? How many of you them can explain the meaning of machining? Okay. Removal of material. Here one of them is saying that removing of material is the machining. Okay. And anybody else? Anybody else? My dear, anybody else? Only one student is saying that removing of material is called as what? Machining. I need some more answer in the chat box. Okay, so let me know. What is the meaning of machining according to you? Yes, people participate. You have to participate, dear. It's your class. So you have to participate in the class, right? So you have to participate in the class. Are you getting my thing? We apply some operation on workpiece to remove extra material. Okay, to remove extra material. Okay. Producing a finishing product by some operation or removing extra material from the raw. Jayesh Patel, you are right, but not completely. 50% answer is correct. 50% answer is correct. Now, I'm giving you a very basic definition to you people. My dear, tell me. Okay, there are products like, my dear, tell me, is the casting is the final product? Is the casting is the final product? Okay, I got it. Removing of material in the form of chip. Okay, casting is not a final product, right? Welding is not a final product, right? Metal forming is not generally what I'm saying. Generally, casting, welding, metal forming is not the final product. After, yes, black fact, you will get your answer very soon at the right point of time. Here, this is not a right place to discuss this thing, right, about the faculty. It is good that you should concentrate on the lecture, my dear. Okay. Yes. So, after casting, after welding, after metal forming, generally what we do? We do machining. At the end, we do machining. What we do? We do machining. Right? We do machining. Now, the question, why? My dear, machining itself. Machining is an essential process. Let me, please hear me carefully. What I'm saying, hear me carefully. Right? Hear carefully. Machining is essential process of finishing. Machining is what? Machining is essential process of finishing, right? Machining is essential process of finishing. Please try to understand. It is essential process of finishing, right? It is an essential process of finishing. Means after machining, you do a finishing process. In finishing process, Generally, what is the objective of the finishing process? Generally, what is the objective of finishing process? The objective of finishing process is to get the desired dimension, to get the objective of finishing, the objective of machining in finishing operation. We get the desired dimension, we get the desired dimension, we get the desired dimension, and B, we get the surface finish, we get the surface finish. Yes or no? Yes or no? My dear, machining is a by default finishing process. Machining is by default a finishing process. By finishing, you are getting the desired dimension and you are getting a surface finishing. If you are not getting, if you are not getting these two things, it means you are not doing finishing, you are not doing machining operation. You are not getting the desired dimension, if you are not getting the surface finish, it is clear that you are not doing finishing operation. Yes or no? Tell me yes or no. Is that point is clear? Is that point is clear? Now I am going to explain to you one more thing. Okay. Now I'm going to explain one more thing. Here there is another word. There is a rough machining. There is another term which is called as rough machining. Rough machining, right? Rough machining. And simply if I say machining, simply if I say machining, my dear, do you know the difference in between them? Do you know the difference? Do you know the difference in between rough machining and machining? Yes, tell me, let me know. Do you know the difference in between rough machining and machining? Yes or no? Do you know the difference in between rough machining and machining? Yes or no? Tell me. Machining, rough machining or machining, do you know the difference? Okay. No, sir. Okay, I'm here. My dear, see here. Suppose that this is your workpiece, right? This is a workpiece. Identically, there is another workpiece, right? Identical, there is another workpiece. First of all, see, right? Here I'm going to discuss this tool right now, right? Here I'm going to discuss this tool. Whenever I'm going to draw this tool, I'm not going to draw this full tool. I'm not going to make this 3D dimension. Even I'm not going to make a complete 2-dimensional. I'm going to make only this part of this tool. So this part is like this. This part is like this. Are you getting? Basically, this point indicate the cutting edge. Yes or no? This point is indicating the cutting edge. My dear, suppose that if you are doing a rough machining, here you can see that you are removing the bulk amount of material. Here you can see the bulk amount of material, my dear. Here you can see that you are going to remove the bulk amount of material. Here you can see the bulk amount of material going to remove in rough machining. In rough machining, it is not necessary. In rough machining, it is not necessary that you will get the desired dimension. In rough machining, it is not necessary that you will get the surface finish, right? You will get the surface finish. Okay. Okay. You will not get the good surface finish. Here, you will not get the good surface finish. See here. But in machining, if I say that the machining is going to be happen, the machining is going to be happen. Look, in machining, are gradually removing. Suppose my dear, I have to remove the same amount of material, but if you are saying machining, if I have to remove that much amount of layer, let's say I have to remove that much amount of layer, with the help of tool, I am going to remove gradually material layer by layer. I am gradually going to remove the material layer by layer. Once I am going to remove this material, then after, what is going to happen? I am going to remove, okay, I am going to remove, see here, I am going to remove here, you can see that I am going to remove, oh my god, what is going to be happen? Yes, I am going to remove that layer. After that, I'm going to remove that layer. After that, I'm going to remove that layer. So gradually removing the excess material. So gradually removing the excess material from the pre-formed blank. From the initial workpiece, this is my initial workpiece. Here you can see that this is your initial workpiece. Initial workpiece. So in rough machining, majorly, we are going to remove a large amount of material in one pass. In machining, we are gradually removing the excess material. Right? Listen me carefully. In machining, gradually removing the, gradually removing the excess, gradually removing the excess material. Right? Gradually removing the excess material from the initial workpiece. From the initial workpiece. Are you getting my thing? From the workpiece in the form of chip. In the form of chip. In the form of what, my dear? In the form of chips. In the form of chip. First, I'm going to remove this layer, then this layer, then this layer, and this layer. So gradually, I'm going to remove the excess material, not in one stroke. Why? If you are going to remove the excess material in one stroke, if you are going to remove the excess material in one stroke, then there is a problem. Then there may be a problem. Whether you will not get the desired dimension, whether you will not get the desired dimension, or not get the good surface finish, right? You will not get, so you will not get your objective. And what is the objective? Desired dimension and surface finish. When you get this thing, good surface finish, and desired dimension, it means that you are doing finishing. That is machining. So machining by default, finishing means desired dimension and surface finish. Yes, so you can see machining, or I can write here finishing. Right? Finishing. Right? Yes, let me know. Yes, let me know. Yes, let me know. Is that concept is clear? Is that concept is clear? Is that concept is clear? Let me know yes or no. In the form of chips, it is obvious that with the help of what? With the help of cutting tool, with the help of cutting tool, with the help of cutting tool, right? With the help of cutting tool. So overall I can say that machining is a removal process. Overall, I can say that machining is a removal process. So I hope you understand the concept of what? My dear, machining. I hope you know the concept of what? Machining, right? I hope you understand the concept of what? Machining. Is that clear? So will it enough for gate? Yeah, it is. It will be enough. Don't worry. Believe is amazing. It is more than enough. Don't worry. Okay. if you have a little bit idea, Manish Kumar, let's say if you have a good concept, if you already know about the thing, so this lecture will be helpful, because here you will get you will clarify your doubt, but not in detail, because as you know, this is a YouTube, and in the YouTube we have a limited time slot. In that time, it is not possible for us and you to interact properly, to get the resolve, to resolve the doubt properly. Right? Okay. So let's move further. Now, what is the shear plane? Okay. What is the shear plane? Now I'm going to explain the concept of shear plane. I'm going to explain the concept of shear plane. My dear, when there is a workpiece, as you can say, this is what? This is the workpiece. See, this is a workpiece, right? When this is the tool, here you can see, this is what? This is the tool. Now this tool is going to do a machining operation. This tool is going to do a machining operation, let's say, and this is known as what? Let me draw. This is known as what? This is the depth of cut. This is what? This is depth of cut. D is what? D is depth of cut. D is what? Depth of cut. Right? D is what? Depth of cut. Now, this is a tool. This is a tool which is moving toward the workpiece. This is your initial workpiece. This is your initial workpiece. Now, this tool is moving toward the workpiece with the cutting velocity V. So, V here is the cutting velocity. V here is what? Cutting velocity. Now, this tool is going to cut the workpiece. Right. Now, when the tool, suppose that when the tool comes here, what is the scenario? Let me draw this figure again. My dear, let me draw this figure again. Okay. Let me explain this figure again. Right. My dear, what is going to happen? Let me explain you. Right? Let me explain you. Let me explain you. Right? Let me explain you. Let me explain you. Here, see. Let's say the tool come here. This is a tool. Right? This is a tool. And here, this is what? This is what? The chip which is going to be produced. The chip which is going to produce here. This is a chip which is going to produce in the operation. This is a chip which is produced in the operation. Right. Once a teacher today is spammer after leaving. No, I'm not going to do this thing. I don't have such time. Okay, extreme motivation. I don't have such time. Don't want to write anything. It's their wish. Right. Here, I don't have such time to stop the spammer. I want to teach here. Okay, I want to focus on teaching. Right. So please see. So here, this is what, my dear? This is a chip. This is what, my dear? This is the chip, right? This is a chip which is moving, which is producing the chip which is removed. Now, here you can see a surface which is produced here, this surface. Are you able to see? This surface is known as a finished surface. This is what? Finished surface. This is what? Finished surface. Which is going to produce in this operation? A surface is called a finished surface. Are you getting my point? Aditya Sir is the best teacher, and PW is an awesome platform for South students. Yes, I'm trying to give you the best thing from my side. I'm only giving my efforts. If you people are thinking that I'm doing good, so I think my efforts are becoming maybe my efforts due to my efforts. Okay, thank you very much. So this is a chip, my dear. Here you can say this is a tool which is moving. Okay, this is a tool. This is a chip. Here, my dear, there is what basically? There is a crystal structure. There is a crystal structure. Crystal structure means what? There is a atoms, right? There is a atoms. This is a crystal structure. There is an atom. My dear, there is a plane. This plane. In this plane, basically, what is going to be happen? A shear force is going to act. A shear force is going to act, and because of this shear force, this crystal structure will break down and it will be produced. Tip here, the crystal, due to shear force, I'm going to write here, due to shear force, due to shear force, shear force, shear force, due to shear force, crystal structure, my dear, crystal structure is going to break down, is going to break down, is going to break down, okay, in a plane, in a plane, and in a plane, in which a crystal structure is going to break down. That crystal structure is known as what? Shear plane. So basically this plane, my dear, this plane, I'm talking about this plane AB. So along this plane, the crystal structure is going to break down because of this shear force. This plane is known as what? Shear plane. So in the shear plane, the material is going to differ. Okay, this is the importance of what? Shear plane. Am I clear? Am I clear? So this is a shear plane in which the crystal structure is going to be what? Break down. Shear force will always be perpendicular to the cutting force. It will not necessary, my dear. Here shear force is going to be produced by the actual cutting force. Here the tool is going to, here the tool is going to give the, here the tool is going to, here R is the actual cutting force. Here R is what? Here R is the actual, right? UAL, actual UAL, actual cutting force. Actual cutting force. Here R is what? Actual cutting force. That actual cutting force basically you are giving to the tool, and because of that, in a plane, you can see, my dear, in a plane, a shear force is produces. This shear force is produces because you are applying the actual cutting force, okay, from tool, actual cutting force from tool, and shear force is produces, within a workpiece. Basically there is a shear plane in which this force is going to be what? Produces. Yes or no? Are you getting the point? So shear force, Fs is what? Fs is nothing, it is what? Shear force, which is going to produce, shear force produces, okay, produces in a shear plane, right? In a shear plane, right? And where is the shear plane? In a workpiece, so it will be produces in a workpiece. Am I clear? Yes or no? Tell me. Am I clear? Yes or no? Tell me, my dear student. Yes or no? Tell me. Yes or no? Tell me. So let me write down. Let me show you the shear plane. So basically, here I'm going to draw the figure in a larger manner. This is a figure which I am going to draw in a larger manner. Please see. Please see. Here, please see. Yes. Please see. Yes. 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 Now see here. This is what? This is a tool. This is what? This is a tool. This is what? This is a tool. This is a tool. Yes, this is a tool. This is basically, yes. Now, my dear, I told you this surface is what? Already I told you. This surface is known as here. This surface is known as your finished surface. Finished surface. This surface is known as your finished surface. Is that clear? Now, this is a tool. My dear, here you have seen that. Here you have seen that. Please see. Here you have seen that. Please see. This is a chip which is going to produce, right? This is what? This is the chip. This is the chip. This is a chip which is going to produce after machining. And this is known as AB. And AB, basically AB is what? AB basically is what? AB equal to shear plane. Again, I am going to explain. Here there will be a crystal structure. This is what? Crystal structure. This is what? Crystal structure. This is what? Crystal structure. Crystal structure. Structure. This is what? Crystal structure. This crystal structure get break down when a shear force get produces. When a shear force get produces. And why the shear force is produced in a shear plane? Because you are giving the actual cutting force. You are giving the actual cutting force by tool in the system, right? So basically what I'm talking about, my dear, this zone is known as what? Your shear plane. In this there will be a crystal structure and they are going to be what? Break down. So my dear, let me draw this figure again. Let me draw this figure again to you people. I told you what is a shear plane. Now you understand the shear plane, right? Now you understand the shear plane. So in a shear plane, what is going to be happen? What is going to be happen? Basically, this is known as, let me write down again, this AB is nothing. This is your shear plane. And can anybody tell me the another name of this plane? Can anybody of you them? Can anybody of you them tell me the another name of this plane? Can anybody of you can anybody from you? Can anybody from you? Can anybody tell me the another name of shear plane? The another name of shear plane is primary deformation zone. The another name is what? Or is what? Primary deformation. Primary deformation zone. Right? Primary deformation. Primary deformation zone. Primary deformation zone. Primary deformation zone. Yes, or sometime we call actually why we say primary deformation zone? Because the initial deformation will take place in this zone. Because the initial deformation will take place, because initial deformation takes place in this plane. That's why we call primary deformation zone or shear plane. My dear, here crystal structure will get breakdown, right? Here crystal structure breaks down, right? Crystal structure breakdown, and then after chip gets produced. Here 70 to 80% power, 70 to 80% of power is consumed, consume. Is that plane is clear? Is that plane is clear to everybody? Is that plane is clear to everybody? Let me know. Is that plane is clear to everybody? Yes. Is that plane is clear to everybody? Yes. Let me know. Is that plane is clear to everybody? Yes, 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 people. Is that plane is clear to everybody? Please comment in the comment box if you understand this plane. Okay, make it the chat box. Make it the chat box red with your yes or hurt. As you wish. As you wish. Sir, more heat generated in secondary deformation, secondary zone or primary. Okay, first of all, try to understand the Jayesh Patel secondary deformation zone. Then you will get then you will know that in which zone the heat is going to be produces more. Right, Jayesh Patel. Sorry. Now, what is going to be happen? Look here, 70 to 80% power is going to be consumed here when the chip moves in upward, my dear. When the chip moves in upward direction, right? So there will be a drag. There will be, suppose this is the face of the tool on which the chip is moving, on which the chip is moving, on which the chip is moving. Now there will be a rubbing in between a freshly prepared chip and the tool face. There will be a rubbing, my dear. There will be rubbing. There will be what? There will be a rubbing in between, freshly prepared chip, freshly produced chip, and clean and surface of the tool and face of the tool and face of the tool, right? And face of the tool. Now what is going to be happen? Now what is going to be happen? Uttarakhand, oh my dear, don't worry, Himmat Singh, I'm coming Uttarakhand, huh? On 2nd of March, I'm coming to Uttarakhand, right? Okay, Himmat Singh, maybe it will be a coincidence if we are going to meet or not, but on 2nd of March, I'm going to come to Uttarakhand, right? So thank you for your love from Uttarakhand, right? So when the chip is moving on the rake face of the tool, then there will be a rubbing. Rubbing is between the freshly produced chip and the face of the tool, right? Then what is going to be produced? Basically a friction. Basically friction. This is what? Friction. This is what? Drag. Friction. Drag in between chip and face of the tool. In between chip and face of the tool. So generally this zone is known as what? Secondary deformation zone. Secondary deformation zone, right? Secondary deformation zone. So this zone is known as what? Secondary deformation zone. Is that clear? Now in secondary deformation zone, due to friction, listen me carefully, Jayesh Patel, listen me carefully. Due to friction in between freshly produced chip and face of the tool, right? Basically, there is a drag. To overcome the drag, to overcome the drag, 32. To overcome the drag, basically here, to overcome the drag, 20 to 30% of power, 20 to 30% of power is consumed. Jayesh Patel, are you there, Jayesh Patel? Are you gone? Jayesh Patel, here 20 to 30% power is going to consume. Here 20 to 30% power is consumed to overcome the drag. Are you getting my thing? Now you can decide by yourself. Now Jayesh Patel, it's your It's your, okay, it's your homework and assignment. You have to think. Now you have to think which zone is more hitter, your secondary or your primary deformation zone. Yes or no, everybody? Is that clear? The secondary deformation zone? Is that clear? The secondary deformation zone. There will be a tertiary deformation zone, which I'm not going to be discussed here because there is no need. Yes, 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 yes. Because there is no need to discuss the tertiary deformation zone because it is so small. Right, everybody? Right, everybody? Yes. Is that point is clear? Everybody? Is that point is clear? Now, I will show you the three-dimensional figure. My dear, shear plane is very important. This shear plane is very important. Very important. Right? Very important. Right? Very important. In exam, in exam, in exam, this shear plane is very important because lot of questions will become. If Manish, you are saying, na sir, is that lecture is sufficient? My dear, whatever I'm going to tell you, please remember those points. This shear plane is very important in the exam because lot of question comes on this plane, right? On this plane. So let me draw the figure again for you people. Let me draw the figure again to you people in 3D. Here this time I'm going to make a figure in 3D. Here this time I'm going to make the figure in 3D, right? Here this time I'm going to make the figure 3D. I will try my best that you will understand the concept, right? You will understand the concept. I will try my best. I will try my best. See, see, please. The figure is very important here. Here, the figure is very important to us, right? If you understand this figure, then nothing is tougher, nothing is difficult. Hey, my dear, yes, which which coolant, beta, which coolant? Don't worry. When we are going to discuss when we are going to discuss about the coolant, liquid, fluid, cutting fluid, then I will tell you. Right? First of all, try to understand now. Now, this is what, my dear. Here you have seen this is a shear plane. Here, this is what? This is the shear plane. That is what AB. Right. Now, here, this is what? This is the width. Right. This is the width W. W is width of the workpiece. W is what? Let's say width of workpiece. W is what? Width of workpiece. Right. W is what? Width of workpiece. Right. W is width of work. Next is your C. This is what? This is the depth of cut. Remember, this is what? This is D. D is what? Basically, I told you. D is what? I told you here. Many times I told you. D is what generally? Here D is what, my dear? D is your depth of cut. This is D. I told you in the initial lecture. D is what? D is a depth of cut. Right? D is what? D is depth of cut. Depth of cut. Right? Depth of cut. Basically, this ABCD, this is a complete shear plane, right? This ABCD is the shear plane, right? Because this figure in 3D, This figure in 3D. Look, this plane. I remove the chip here. I remove the chip here, and please see here, this is the shear plane. I'm making red because here heat is going to be produced. Am I clear? I'm making red because lot of heat is going to be produced in the shear plane. In the shear plane. Yes or no? In this plane, basically along this plane, a shear force is acting. Along this plane, a shear force is acting, right? A shear force, Fs is what? Fs is shear force. Shear force which is acting, and because of this shear force, the crystal structure gets breakdown. Because of this shear force, the crystal structure gets breakdown. Am I clear? Yes or no? Yes or no? My dear, the inclination of the shear plane from the horizontal line is known as, the inclination of the shear plane from the horizontal line is what? That is a shear angle. That is a shear angle. Please remember one thing. This shear angle is constant. This shear angle is constant. It is not going to change throughout the machining. This shear angle is constant. It is not going to change throughout the machining if the other parameter are constant. And what are the other parameter? Like your cutting velocity, like your depth of cut. My dear, you are going to cut. My dear, here you have seen you are going to cut that much thickness before cutting. That much thickness before cutting. So this thickness is also known as what? T naught. And T naught is nothing, uncut thickness. Uncut thickness. Uncut thickness. Uncut thickness of chip. Right? Uncut thickness. Am I clear? And from this figure you can get that depth of cut and uncut chip thickness. Uncut thickness of chip. Uncut thickness. Okay, uncut chip thickness. This is known as what? Uncut, uncut chip thickness. Uncut chip thickness. Uncut chip. Yes or no? From this figure, you can understand that uncut chip thickness, T naught is the uncut chip thickness because it is before cut. It is before cut. And T naught is a perpendicular distance basically. T naught is what? The perpendicular distance from the top layer to the bottom layer. Am I clear? Okay. Now here I can write that. That is also equal to, I can write that. That is what? That is what? I can write that. I can also write it is what? It is T naught, or I can write that depth of. Yes or no? My dear, shear angle will be given to you. Let's say shear angle is what? Cutting parameter. Here, phi, W, T naught. These are what? These are cutting parameter. Cutting parameter. Yes or no? These cutting parameter, you know very well. I mean, this cutting parameter is given to you. This parameter is given to you during cutting operation, right? And this is the workpiece, and for the workpiece, yield shear strength. Yield shear strength. Yield shear. My dear, what is this surface? Tell me, what is this surface? This is the surface finish, na? This is a finish surface. This is what? Finish surface which is spread. My dear, because of this shear force, the crystal structure breakdowns. Because of this shear force, the crystal structure breakdown. Can you find out the shear force value? Can you find out the shear force value? Yes, we can find out the shear force value. The shear force equal to your yield shear strength of the workpiece into shear area. Yes or no? Shear plane area. Shear plane area. Now, what is the shear plane area? How will we handle numerical based on shear plane? Yes, Manish Kumar. Today is the first class. At least try to understand the basics. Then after you can manage the numerical also. Then you can able to solve the numerical also. Don't be in hurry. Everything will be completed step by step. Are you getting my thing? Everything will be completed by step, not in a jump. If you complete within a jump, so you will leave many important concepts. Do you want? No, we don't want to skip many other important concepts. Right. So we are going to do a step by step. Now, this is what here. This is the part of your numerical problem, Manish Kumar. This is the part of your numerical approach, right? So this is a shear force. How can we find? This is a shear plane area. This is what? This is a shear plane area. Please see. This is what? This is a shear plane area. My dear, shear plane area. Let's say the shear plane area will be what? Width of the shear plane AD into AB. My dear, AD is almost equal to width of the workpiece. Width of the workpiece. My dear, here this is a perpendicular. Please see in the triangle AB, let's say C. Okay. In triangle ABC. My dear, sine phi equal to perpendicular, that is what? T naught divide by AB. So AB equal to what? T naught by sine phi. Yes or no? Yes or no? Are yes or no? Sine AB equal to T naught by sine phi. So AB equal to what? T naught by sine phi. So let's say shear plane area is denoted by AS. Now you know the value of shear plane area. So what will be the shear force? Yield shear strength that is given to you. Yield shear strength that is given to you into shear plane area, and tau naught into shear plane area, that is W T naught divided by sine phi. That is your Fs. Yes or no? Tell me. Yes or no? Are you getting this thing? So this is a very important concept. This is a important thing. You don't have to remember the formula, Manish Kumar. If you people are thinking to remember the formula, then it is a useless. Try to understand the concept. Try to understand the concept. Okay. Now, this is the part of your numerical. In a lot of gate exam, the examiner is going to ask the value of shear force. The value of shear force if the cutting parameter is given. Is that clear? Is that clear? Yes, everybody. Is that clear? Yes, everybody. Is that clear? Tell me. Tell me. Is that clear now? Okay. So this is the important thing. Now, in the next topic, I'm going to discuss about what? About the tooling angle of simple cutting tool. I'm talking about what? I'm talking about this basically. Right? I'm talking about, see, I'm talking about this simple tool. I'm talking about this simple tool. See, see. Remember this tool? Remember this tool? My dear, this is what? See, yes. Remember this tool? This is what? Cutting edge. Cutting edge. My dear, this surface is known as rake surface. Rake face. Why we call a rake face? My dear, the definition of rake face is very simple. Right? Now, if you are going to draw this tool in a simple way like this, right? If you are going to draw this tool in a simple way like this, please see. If you are going to draw this tool by a simple way like this, please see. Now the chip is moving. Now the chip is moving on this surface, right? The chip is moving on this surface. See, the chip is moving on this surface. The chip is moving on this surface. This. Now the chip is moving on this surface. Now the rake face is the surface. Now the rake face is the surface along which chip moves upward. So this chip is moving along this face, and this face is known as what, my dear? That is what? Rake. That is what? Rake face. So basically, the definition of rake face is crystal clear. The definition of rake face is crystal clear, along which the chip moves, right? Along which the chip moves, along which the chip moves, that surface is known as what? Along which the chip moves, along which the chip moves, along which the chip moves, that surface is known as what? Your rake face. Chip moves upward. Chip moves upward, right? Upward. Yes. 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 Now, my dear, please see, during cutting operation, this face which is toward the workpiece, I'm talking about this face of the tool. This face. This face is known as what? Flank. This face is known as what? Flank. Basically, flank which is toward the finished surface. Basically, this face is toward the finished surface. So that surface of the tool is known as what? Flank. Flank. Flank is always toward the workpiece. Flank is always toward the workpiece. Flank is always toward the workpiece. This is what? This is flank. Yes, this is flank. Flank is which is toward the workpiece during machining. Is that flank and rake surface is clear, or rake face is clear to everybody? Okay. Generally, we say this is a rake surface, not face. Rake surface. This is a rake surface, right? Rake surface. Is that rake surface and flank is clear to you? Is that rake surface and flank is clear to you? Yes or no? Is that rake surface and flank is clear to you? Yes or no? Is that rake surface and flank is clear to you? Yes or no? Okay. Okay, now is that rake surface? Okay. Now I'm going to discuss about some angles. Now I'm going to discuss about some angle. My dear, there is an angle which is known as, right? There is some angle which is known as what? My dear, you have seen that this is a tool. You have seen that this is a tool, right? You have seen that this is the tool. This is the tool, right? This is the tool, and this is basically this line. Please see, this is a dotted line, right? Please see, this is a dotted line, and this line is along the finished surface, right? This line is along the finished surface, right? So this is perpendicular. This is along the finished surface. This line basically along the finished surface. Finish, right? Along the finished surface. My dear, this is what? If the chip is flowing, if the chip is flowing from here, 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 then this surface is known as what? Rake surface. Already you know that this surface is known as what? This surface is known as what? Rake surface. Rake surface. Rake surface. Right? This surface is known as what? Flank. Right? These two surfaces are clear. This line which is perpendicular to the finished surface is called as normal line or reference line or reference line, right? Or reference line, normal line or reference line. Yes or no? This line which is perpendicular to the this line which is perpendicular to the finished surface is known as what? Reference line. Let me know. Is that reference line is clear to you? Is that reference line is clear to you? Are Baba, let me know. Is that reference line is clear to you? Yes or no? Now the inclination of rake surface from the reference line. The inclination of the rake surface from this normal line is known as rake angle. Alpha is a rake angle. Alpha is what? A rake angle. Right. Alpha is the rake angle, that is the inclination of rake surface. Inclination of rake surface inclination of rake surface, right, from reference plane, from reference flame from reference flame from reference plane or normal line or normal line or normal line. Is that angle is clear? Is that angle is clear? Is that angle is clear? Are Baba, tell me, is that angle is clear? Now flank, the inclination of the flank from finished surface. This is what? Finished surface. That is what? Clearance angle. That is what? Clearance angle. So it is basically clearance angle, right? It is basically what? Clearance angle. Angle of inclination, basically flank surface clearance angle, which is inclined from what? Finished surface. Yes, which is inclined from what? Finished surface. So do you people have any doubt? You can ask. So this is today's lecture basically. Okay, this is today's lecture, and thank you very much. Meanwhile, if you have any doubt regarding today's lecture, you can ask. If you people have any doubt, you can ask regarding this lecture. Yes, if you people have any doubt, you can ask regarding this lecture. If you people have any doubt, you can ask regarding this lecture. Regarding, keep in your mind what I am saying regarding this lecture, not other question. I'm not going to entertain other question, right? I'm going to entertain the question which is relevant today's lecture, which is relevant to the today's lecture, right? Which is relevant to the today's lecture. Yes, yes, everybody, tell me, is there any doubt? Yes, is there any doubt? Yes, tell me, is there any doubt? Yes, is there any doubt? Tell me. Sir, your lecture style is superb. I love that. Thank you, Manish Kumar. Hima Singh, no doubt. So we are going to Hima Singh. We are going to meet, huh? In your Uttarakhand. on 2nd of March. So on 2nd of March, I will be in Uttarakhand, right? Yes. Okay, no doubt now? No doubt. Okay. So here I'm going to stop this lecture. I hope you enjoyed this lecture, right? So tell me how many of you them, I mean, in which year you are? Tell me, in which year you are? In which year you are? My dear, tell me. Manish Kumar, in which year you are? Final year. Jayesh Patel in final year. Shirish Ravi in fourth year. Final year means, okay, Himmat Singh is also in final year, right? Good. So I think three people are in the final year. Let me know the rest of people. Manish Kumar, in which year you are? Are you dropper or second year, third year, fourth year? In which year you are, Manish Kumar? Yes, Manish Kumar, in which year you are? So I'm assuming that all of you are from final year, right? Okay, not an issue. All of you are from final year, right now? Okay. Okay, then we are going to stop the lecture. Thank you. So today we are going to meet with a new topic, right, of the theory of metal cutting. We are going to continue the theory of metal cutting. So it's my humble request that before coming to today's lecture, today's lecture, you should revise the previous lecture, right? Every day, at least, please give your 10 minutes for revision. Every day, please give your 10 minutes for the revision. Okay, my dear student, will you give your 10 minutes for to the revision? Hello, will you give your 10 minutes to the revision? Will you give your 10 minutes to the revision? Yes or no? Yes, now. So please do the revision properly every day. So then after these lecture or these series will be beneficial for you. Notes are available in the app, sir. Yes. Yes, Sirish Ravi, notes are available in the application. Right? In the app, you can download these notes. In the app, you can download these notes. Not an issue. In the app, you can download these notes. Right? Okay. Okay then, everybody. Bye. Good night. Take care. Tomorrow we are going to meet. Okay. Sir, will other subject will start parallel with these class. No, my dear. Once I'm going to complete this lecture, Jayesh Patel, once I'm going to finish in English channel, there will be a production in English channel. Strength of material is going to be run. If you are comfortable with Hindi and English both, so at 8:30 there will be a strength of material lecture on English or your mechanical English channel, right? In English. So from 8:30 to I think 10 p.m. there will be a strength of material. So one lecture will be on English channel, right? One subject will be on your English channel and one subject will be run on the English channel. Am I clear? So if you are comfortable to both Hindi and English, then you can attend both the lecture. If you are comfortable with English, then please stick with this English channel. Right? Okay? Okay? Okay, my dear? Okay then. Thank you. We are going to meet tomorrow. Thank you.